Hey everybody, this is Mr. Ainsworth, and we're going to get into the 11th lesson here in our Unit 1 here, and we're going to be solving equations, but this time we're going to be justifying each step as we go, showing all our side work, but justifying as we go with the property of equality in mathematics. Okay, we got to state what allows us to do the things that we do in algebra. Okay, so let's go review the properties and then we can go for it. It's going to test your skills because not only do you have to solve it, but you actually call it the correct property as you go. You know, what property allows to do what you want to do, okay? Now the reflexive property here states that we got x equals x, okay? That means that a number equals itself, like 5 equals 5. All right, we're probably not going to be using that, but it's a property, and it sure makes sense because, you know what, a number does equal itself. No big deal. It's kind of goofy, but it's true. All right, the symmetric property. We use this sometimes because I switch the sides of an equation sometimes. You know, if x equals y, then y equals x. You're allowed to switch the sides of equations, and the order of the equality doesn't matter, okay? I use that property sometimes, and when I do, I'll quote the symmetric property. All right, the transitive property is used sometimes. All right, if x equals y, notice that these two are the same. All right, and y equals z, well then they're basically all equal together, or they're all equal to one another, and x equals z. All right, if the first equals the second, and the second equals the third, then the first equals the third. All right, basically what I'm saying is that if x equals y and y equals z, then obviously x equals z. All right, it's a basic equality. Okay, it's called transitive property. The addition property. Now the addition property and all the rest of them here are the ones we're really going to be using here. And what it's stating is that you're allowed to add any real number to both sides of the equation. So if x equals y, then you can add z to both sides, no problem. And z is any real number. Z can be any real number. It can be negative, positive, fractional, decimal, whatever. But it allows you to add any number to both sides as long as it's the same value. The subtraction property allows you to do almost the same thing. It allows you to subtract the same number on both sides of the equation, and z can be any real number. The multiplication property allows you to take a number and multiply both sides by it. Okay. So if x equals y, then x equals yz. Notice that you're multiplying both sides by z. That's called the multiplication property of equality. The division property allows you to do the same thing, but you got to be a little careful here. If you have an equation you want to divide by z, well, go ahead. All right, the only number that you cannot divide by is 0, okay? Z can't be 0. This is the not equal to sign. So the denominator right here, okay, z can never equal 0. Remember that. Can't divide by 0. In fact, let me write that down. You cannot, all right, divide by 0. All right. Not only does it not make sense, but your teachers taught you that ever since grade school. Okay, it's not allowed because it doesn't make any sense. All right. Substitution property. That's when you replace one thing for another thing when two things are equal, and they have to be equal, by the way, if you're going to be substituting anything. And this one here, the distributive property, we're going to use this from time to time. If you're taking a number and multiplying it through a group, all right, like this right here, x times y plus x times z, well, that's the distributive property when you multiply a number through a quantity, or what I say, a group. All right, we're going to use this one a lot here. We're going to use the subtraction, the addition, subtraction, multiplication, division a lot, and the distributive a lot in most of our problem-solving process. And once in a while, if I switch the sides of an equation, I'll use this one too. It may or may not happen, but it does happen sometimes. Okay, so just remember what you normally do is justified by these properties, and these properties are what the teachers have taught you throughout the years as you go through your algebra. Okay, now let's take a look at our first example. Get out your red pen, all right, like I have here. We're going to show our steps in red, and this is not supposed to be there, so let me erase this. I don't know how that got there. All right, so pretend you didn't see that. All right, and what we're going to do is we're going to show the steps in the first column. We're going to justify with the properties in the middle here, and we're going to do all our side work here. Okay, so in the first column, check it out. We're going to show our steps, show all steps, and let me see the justify it here, and show your side work. Okay, so we're going to make that commonplace as we go do that. Now get out your red pen. We're going to show the steps in red, as I stated right here. Show all steps in red. Now we're going to try to solve this equation. We've seen these before. All right. Put a lot of fractions in here so to test our skills. We're going to take 2 times the number plus 2 1/3 equals 9, and we're going to solve for that unknown. All right. Now I see a plus 2 1/3. So what I want to do is add the opposite, or subtract 2 1/3. I want to do that in red. So get out your red pen and subtract it. 2 1/3 on both sides. All right. And at this point, 2 1/3 minus 2 1/3 cancels to 0. And you get right here 2x is equal to whatever this is. All right. Now hang on for a second. Before we do this, all right, what did we just do right here? We subtracted the same value on both sides of the equations. All right. Now, as I said earlier, everything is backed up with a property, and what we just illustrated was this property right here, that if x equals y, then you're allowed to subtract the same number on both sides of the equation, as long as that number is the same. That's called the subtraction property. All right, so basically what you do is how you justify it. So we're going to write it down, subtraction, all right, property. PROP is property in short, okay, subtraction property. We do all the side work over here. We've got to take 9 minus 2 1/3. So 9 minus 2 minus 1/3. So 9 minus 2 is 7 minus 1/3. Well, that's under 7, right? If you take one part out of 3 away, all right, 2 parts out of 3 remain. All right, and you don't have 7 anymore. You have 6 wholes and 2/3 remaining. And notice how I step it out. I've showed you this technique many times, okay? And you get 6 2/3. All right, so we're justifying as we go in the middle here. We're showing our side work over here. All right, now what we want to do is handle this. This 2x right here is 2 times x. All right, and you could divide by 2. Okay, you can choose to use the division property right here, or you can actually multiply by the reciprocal. All right, get out your red pen and let's do that. Let's multiply both sides by half. And let's justify it right there. That's the multiplication property of equality. Okay, multiplication, all right, property. Now in the future I use SUBT for subtraction, MULT for multiplication, and PROP for property. So we write it out in the first few examples, but then we'll abbreviate a little bit later on. Okay, so we're allowed to multiply by the reciprocal, which is 1/2 on both sides. Now the cool thing about that is that 1/2 of 2 is 1, and 1 times x, well, that's x, right? That's the multiplicative identity property of 1 right there. All right, so we got or multiplicative inverses, actually, if you really want to be technical here. But 1 times x is x here, and that's going to be equal to whatever this is. And once again, we do some side work over here. So 6 2/3 times 1/2. All right, now let's change this to, let's change, well, you know, we could take 1/2 of 6 and 1/2 of 2/3. That's probably the easiest thing to do. That's the quick thing to do, right? Here, let me show you something. 1/2 times 6, well, that's 3. And then 1/2 times 2/3, well, that's 1/3. All right, so the answer is 3 1/3. All right, now if you didn't follow that, here's how your teachers taught you in grade school. They said change this to improper. All right, 3 times 6 is 18, plus 2 is 20. So you get 20/3 times 1/2. Do a little division here. Okay, 2 into 20 is 10. And the answer is 10/3. And guess what? 10 divided by 3, that's 3 1/3. So you know the same. So you can do it the quick way like I did, or you can do it the old school way. It doesn't matter, you're going to get the same result. Okay, so we got 3 1/3 here. All right, and so we get x equals, let me just state it right here. Let me make it real clear. X equals 3 1/3. So first we use the subtraction property of equality, and then we use the multiplication property of equality. So it's not any harder than what we've done before. You're just stating a few properties, doing your little side work over here, and showing everything as you go. So let's try it again. Now this one here, we have a couple different options. We can distribute through the 6 times the quantity, 2x minus 3 equals 42. We can distribute through, Or if we wanted to, we could divide both sides by 6. In fact, I would probably do that if I was doing it. But I want to kick in the distributive property here first. So just to do something, to use another property, that's all. Okay, that's all there is to it. So let's do it. 6 times 2x is 12x minus 6 times 3 is 18 equals 42. All right, and right there, I just illustrated the distributive property. So nothing new, it's just justifying with a property as you go. All right, at this time, I want to add the opposite again. So if I see a minus 18, I'm going to add the opposite, which is a positive 18 to both sides. All right, I'm allowed to do that. Right there, that's the addition property of equality. Okay? Addition property allows you to add the same number to both sides. All right? Opposites cancel to 0 here, and we've got 12x is equal to, let me see, 50 and 10, 60. All right, so now, what do we want to do? Let's see, we want to divide, this is 12 times x, right? So we want to divide both sides by 12. Right here, simplify a little bit, 1 times x is x. All right, I should probably state the property for that. I don't know if it's in the list up here. No, but so I won't be too technical. That's good enough. All right, and then, wow, 60 divided by 12, well, let me say that's 5, because 5 times 12 is 60. All right, so x equals 5. Right here, that's your division property of equality, right? Because you're allowed to divide both sides by the same value as long as it's not 0. All right, division property. So you're just explaining as you go. Do a little side work if you need to. There really wasn't any side work needed here because most people can do that in your head, but if so, work it out on the side. All right. So let's get some more experience here. I got 2/3 x minus 3 equals 10. Get your red pen out and let's add the opposite here. And again, we're going to use the addition property. It allows us to add any constant to both sides. These cancel out to 0, and you get 2/3 x plus 0, which is 2/3 x, is equal to 13. And what I want to do now is take that equation and solve for x, and this is 2/3 times x. So once more, I want to multiply by the reciprocal. All right, so we're going to multiply both sides by the reciprocal, which is 3/2 here and here. All right, you can say multiplication property, or you can say multiplying by the reciprocal. It's actually both. Multiplying by the reciprocal. That's how I've taught you guys, and that's how they started this back in 5th grade. Now, whenever you multiply by reciprocals here, you get 1. All right, 6 divided by 6 is 1. 1 times x, well, guess what? That's x, right? That's actually a property, but like I said earlier, I'm not going to get too technical here. 3 times, or 13 is not divisible by 2, so we have force to multiply here. 3 times 13 is 39, so we get 39/2. All right, take 39 divided by 2. 2 into 19 is 9, remainder 1, so it's 19.5. So x is equal to 19 1/2. Okay, you go from improper and you change it to mixed form. All right, you basically divide. So it's not too bad, my friends. You just justifying and solving equations like you normally do. Okay? All right, I'll tell you what, I'll do one more and then you guys can do the rest. Okay, maybe, well, 1 or 2 more. Okay, so on this one here, I have x divided by 5. Notice I said divided by right there, not over. Plus 3.5 equals 13. Well, get out your red pen again. I want to subtract 3.5 on both sides. All right. These opposites cancel to 0, and you get x divided by 5 is equal to something, right? So let's justify here first. Use the subtraction property first. All right. I'm going to do my work over here. 13 minus 3 minus 1/2. That's 10 minus a half, that's 9.5, right? So you have 9.5 here. So I state my property that I use in the middle, justify it with side work on the side. All right. Now, the inverse of division is multiplication, so I can multiply by 5, or I can think, okay, multiply by the reciprocal again, and the reciprocal of 1/5, well, that's 5, right? So I want to multiply both sides by the reciprocal, all right? So I want to kick in my multiplication property, that's PROP, guys, or you can say multiply, all right, by the reciprocal, like I wrote down earlier. Write down both, okay? Because you're trying to get good here. You're trying to get good at explaining, showing your steps, and justifying as you go, and doing all your side work. Okay, so this is really pushing the limits here for you guys, because some of you guys, this is the hardest thing there is displaying your ideas, explaining your work, okay? And I'm trying to show you how to do that. All right, now 5 times 1 is 5, divided by 5 is 1. 1 times x is x. All right, you want to multiply here. 5 times 9, 45. 5 times a half is 5 halves. Now 5 divided by 2 divides, let me bring this down so we can see it better here. 5 divided by 2 divides 2 times, remainder 1, so 2.5, right? So this is 45 plus 2.5, 47.5. All right, you got to change this to mixed and then add to the whole number. This is something I've taught you before too in all our skill work. Okay, and I'm just going to add a word here, simplify, okay? Always taught to do that. All right, and I'll tell you what, I'll do one more with you guys, and then you do the rest. All right, so let's take a look at this one here. You got 4y minus y plus 5 equals 6 1/3. So as you guys are trained usually, you're trained to simplify first and add like terms. So these two right here, you know, 4y minus 1y is obviously 3y, right? 4 minus 1 is 3. Plus 5 equals 6 1/3. All right. Simplify. You can say or add like terms, okay? Or add like terms. Why? Because we're explaining, we're justifying. That's the whole thing, that the whole part of our lesson here, the main part of our lesson is learning how to explain why you can do what you normally do, okay? That's what you want. You want to be able to write it correctly, do it correctly, justify it correctly, and show your side work correctly. So it's a multi-step process. All right, and I see 3y plus 5, and I see this plus 5, well, I'm going to subtract and do the inverse here, which is a minus 5. These cancel. And I get 3y is equal to 6 1/3 minus 5. Well, that's simple. 6 minus 5 is 1, so you get 1 1/3. Okay? So how did we do that? Let me see. We simplified right here and then right here. What would we do there? Well, we use the subtraction property, right? Because we subtracted in red 5 on both sides. Subtraction property. Now what? Well, we got 3 times y. So we can either divide and use the division property, or we can multiply by the reciprocal again. What do you guys want to do? Well, you know what? I'm going to do it a little bit differently than before. Before I multiplied by reciprocal. This time, I'm going to divide by 3. What the heck, man? It's the same thing, right? So I'm going to divide here and simplify. And I get y is equal to something here. Now, let's do this on the side. 1 1/3 divided by 3 is the same thing as 1 1/3 times the reciprocal of 3, which is 1/3. All right? Write down multiply by the reciprocal. The funny part about this is that you can divide here and you quote the division property right there, which I'm going to do because that's the way I chose it. But every division problem, you're going to multiply by the reciprocal anyways, and that's why I typically do that. I multiply both sides by 1/3. Because that's what's going to happen when you change your division problem here to a multiplication problem. You're going to take the numerator times the reciprocal of the denominator. And then you're going to, once again, do everything like you did in 5th grade. So 1 1/3 is 4/3 times 1/3, and that gives you 4/9, right? You got to change your mixed to improper. 3 times 1 is 3, plus 1 is 4, 4/3, times the reciprocal of the denominator, which is 1/3. Multiply the numerators. Look at this. Multiply, you get 4. All right, and then multiply the denominators, and you get 9. So 4/9, right? So you get y equals 4/9. All right, and to get from here to here, you obviously do a little simplifying again. And that's what I did over here. You simplify, you divide, and you do your basic arithmetic. So first I simplify and add like terms. Secondly, I subtract 5 on both sides. That's subtraction property. Then I divide both sides by 3. That's the division property. And then I do my arithmetic on the side. Okay? And that is how the game is played here. You know what? Let's do this. Let's do something fun here. This one here, I'm going to go one more here. And what I want you to do, though, is be careful how you write this. Okay, we're going to use kicking the distributive property here, and do a little simplifying here. So let's kick in your distributive property, and let's multiply both terms by 3/5, distribute it through, and be careful how we write it. 3/5 times your first term, which is 15p. Notice I put in parentheses here, minus 3/5 times your second term, 20, equals 6. All right. Notice how I multiply both terms by the 3/5. I distribute it through, and I multiply both terms. So let's quote the distributive property here. All right, PROP's property, as I said earlier. All right, now let's simplify a little bit. It's always easier to divide if possible. 15 is divisible by 5 3 times. 3 times 3 is 9, times p is 9p. Minus 5 into 20 is 4. 4 times 3 is 12. All right, equals 6. So we want to simplify, okay, the expressions in through here. I want to add the opposite here, because now I have 9 times p minus 12. Well, I'm going to add 12 because we always add or subtract first if possible. This tends to be easier to avoid fractions. So I'm going to use the right here. I'm going to use the addition property. Addition property. And then I'm going to simplify a little bit. I got these opposites. Negative 12 plus 12 is 0. I get 9 times p, or 9p, equals 18. All right, now 9p is 9 times p. And I say that because I want to do the inverse. I want to divide both sides by 9, right? So I want to kick in the division property. Why, right? Why? Because we're dividing both sides by 9. All right, do a little simplifying. 1 times p is p, and that's equal to 2. All right, no need to do any side work here. Let's put not needed. All right, and that's how the game is played. So what I want you to do is turn the page, and now you got, I think, 3 examples. 1, 2, 3. All right, try those, and check those with me, and make sure you show all 3 things. I want you to show all steps. All right, I want you to justify as you go, and I want you to show the side work. Okay, make sure you do that, and then check all your work with me, and then we'll see how it goes. All right, and we'll talk individually one-on-one. All right, this is Mr. Ainsworth. I'm signing off here, and remember, this is a video, so if you'd like, you can go out back to the beginning here and review anything you like. All right, you can pause and play, review any of one of the examples, and just give it your best shot. You got 3 more to do. I think you can handle it, and I'll see you in my next lesson. This is Mr. Ainsworth. I'm signing off. I'll see you then.